Okay, thank you. Everybody's here. This is my biggest class. I'm so excited for you guys. Okay, so let's go do some other things. And we've done the chat thing, and I'd like to review some resources. So I'm going to do a share screen. And some of you have done this and some of you haven't, but I want to point out a couple things to you. So I'm going to do a share screen and go to my desktop, share, okay. And I'm going to go to Schoology, and I'm going to do here and go to our class, which is period 3. I'm going to make this slide bigger. And does anybody know what Nashaya Komin means? Anybody know what that means? Okay, here you go. It means greetings, human. All right, in Vulcan language. Okay, I just thought you'd want to know that. Okay, funny, huh? My daughter made up this scene for us last Saturday. Okay, so on the next page it says course description. I'm going to go through this and hit some things that probably are different for this course than all other courses you've ever taken. So let's see how this works. You ready? And if you have a question, you have to speak up because I don't see all of you anymore. You ready? Let's go down. There's 10 units in this course. We're going to do the first 5 in the fall, and those are basically about motion. And then in the spring, we're going to apply those things to other kinds of motion, which is up and down and around, and charges, circuits, and waves and sound. So that's how we'll finish up the end of April, and then our test is in May. After the AP, we're going to do contests. I love contests, such as bridge building. You probably heard about that this past May. We had a great bridge building contest. All right. Course objectives are down here. Please note, this is from AP Central. Save your lab notebook or a book that has your lab work in it. At St. Martin's, when I was there, we had a lecture course for 4 hours a week, and then we had a lab course. I think it was 3 hours a week, but that was 7 hours. So there's separate credits. So you could get a lot of credit if you keep your lab book and your college accepts AP scores. OpenStax College Physics. You people that are on the side, wave your hand if you've already seen the OpenStax College Physics book. You guys that are over on the side. None of you? None of you seen it? Oh my, okay, you can get to it. I'll show you, I'll open it up for you today just so you can see what it is. You'd probably like to have a binder to keep your notes in, okay? $20 lab fee to ASB. This is pretty important. Since we don't have a textbook, we need to have a homework program called WebAssign, and that allows me to assign homework. And I can put all kinds of little things on there, like you get hints, you get second chances, all that kind of stuff. So the homeworks will be allowed to be redoable until you take a test on it, which is about every 2 or 3 weeks. You can keep redoing the homework and improving your score and all that stuff. And that's going to be also true for quizzes. We'll probably do that on WebAssign too. The other $7 or $8 goes to paying for the materials for our contests. Egg drop, bridge building, marshmallow towers, those kind of things. AP Central, please note your P3 right there. Do you see that? That join code for AP Classroom for this course and this class is PD9AVV, I think it is. Make sure if it's not, you're going to tell me. Okay, I want you to join AP Classroom, and please put yes, you're planning to take the exam. I hope that everyone plans to take the exam. I think it's $90 or so, and you can actually back out of that even the week before the exam. So, my goal is to have 100% of my students take the test and pass it with a 3 or 4 or 5. That's my goal for this year, and I'd really like to meet it, okay? So you're part of that solution to that goal, all right? Classes, I assume we're going to be doing this probably through the whole first semester. I hope we get to see each other live in the spring. Conferences, you can ask me a question at any time. Just send me an email, and it might require some kind of a little snapshot of your problem that you're doing, and I'll try to get you over the hurdle that you're at. Homework, about 30 to 60 minutes for each next class. That's 3 days away, so that's about 20 minutes, 20 to 30 minutes per night, unless you want to do it every other night. Okay? I haven't posted it on Schoology. I'm sorry, I forgot to do that. You know, here's what you're supposed to read, here's what you're supposed to do, watch, and turn in, all that kind of stuff. I forgot to do that. We'll do some formal labs, maybe one a month. Computer use, you know about all that stuff. Quizzes may be given at any time. Short ones, you can take them over if you didn't get 100. Tests will be probably every 3 weeks or so, over a chapter or two. Open book, open notes, just not open people. So if your mom or dad's a PhD in physics, you can't have them take your test for you. That's a joke. Homework will be due before your quizzes, before your test actually, and then after that it's a 0. But up until then you can take it, and it's for practicing for the test. There'll be a final exam each semester, cumulative. Classwork, these percentages are not set in stone yet. I'm not sure about them. I just set them there. This is the grading scale for the whole high school. Somebody remarked this morning that says, wow, a C is 76 down to 60. Well, they don't want anybody to get lower than a C. So I expect all of you to get A's or B's in here. If you're not, I'm going to be on your case about it, okay? Integrity down here says that if you copy somebody else's work and turn it in as your own, you both are in trouble. That's one way you get kicked out of places like St. Martin's University, is if you copy somebody's paper and turn it in as if it were your own. Now, this next part is unique to our class. I want you to really look at it. It says if you score a 3, 4, or 5 on the AP exam, I will go back and update your first and second semester final grades and give you an A if they weren't. Now, this past year, most of the kids that got 3s, 4s, and 5s had A's. So I didn't have to change but 7 kids' grades that didn't have exactly an A first semester. So it's kind of an indication. If you're getting an A or B in this course, you should get a 3 or 4 or 5. Okay? Qualifications, we don't know the format of the exam on May the 5th next year at noon. We're not sure. But certainly if you pass this AP, it's going to be a good mark on your record and something to brag about to your colleges. Zoom expectations, I'm sure all of you are polite. You're not going to be rude or do all these things in the back, okay? If not, we'll talk. Take responsibility, you know all this. Please help. I'm thinking of giving you a lab partner. We'll talk about that next week. Giving you somebody that will do homework with you, labs with you, at least online, so that you can have somebody to share with. So I always do that in class. Everybody has a study partner. Okay, let's go on down. Conference times. I'm going to try on Mondays and Thursdays, the days we have class. If you look up there, from 3 to 4, you'll get an immediate response from me for questions. I'll be watching my inbox and just kind of do that. I don't know if we'll need to do individual Zooms. I'm not sure about that yet. So on Mondays and Thursday afternoons from 3 to 4, those will be my office hours. And but I'll answer a question day or night. I may not get to it at midnight, but I'll answer any question that you email to me. This top 10 reasons why you should take physics is from a website for physics people. And notice the #1 reason is that you're going to be more attractive to university recruiters, future employers, and that cutie you have your eye on. Now, I didn't write that. All right, this just came on the graphic. So, but physics students are more attractive period. In the corner it says, I love you and WizKid. Okay, that's you guys. So there's many things up here to think about. I hope you look at it sometime. It's a cool graphic though. Alrighty, let's go back now and let's pick something else that's on here. This is the equation sheet that you're going to get to use on all quizzes and on the AP final. So these values, notice on the left are the prefixes you're supposed to be able to use. You don't have to memorize them. And on the top are only the constants that we're going to use with our 10 units. All right. And then trig, if your calculator dies, you have to use trig, those trig values if your calculator dies. The equations you can see are broken up into mechanics, which is most of the year, and a little bit of electricity and waves in the spring. So those you're gonna know those equations. You won't even have to look them up. You're gonna know them. Okay, kind of like vocabulary for a foreign language. All right, enough of that. Let's get rid of this thing. Let's see if I can get rid of this. Okay, how do we get on here? Let's go back here, and let's go back here. There we go. Let's see, what else is here? College Board by AP. I showed you your access code, but you should have that ready to go. Then OpenStax College Physics book. So this is a bookmark, and you can see that this goes page by page, but I have mine actually as a PDF on the side. So notice that chapter 1 is what we're going to do. We're on an introduction today, quantities, accuracy, precision, significant figures, and approximation. I'll do most of that today with you, and it ends about on page 30 with some questions and problems. So this is a beautiful book. They've really thought about it, and it's free. So there's some great graphics. There's also some connections with computer programs, some simulations and things like that. And it's got some profiles, which I think make it really good. So please explore that, read it. I don't know how long it'll take you to do this, but it depends on your reading. So any questions so far? 120 to 150, okay. Let me go back now. And I'm gonna stop sharing this thing here. Okay, if I can find it again. Stop sharing. There we go. Okay. Whoo. Okay. So we've gone a half an hour, and that's kind of a good time to take a little break. So I've got 10 till 2. So let's take a 5-minute break. I want you to stand up and stretch. If you don't have your can, your ruler, your paper for taking doing some calculations, go ahead and get that now. But if you want to stand up and stretch, I'm going to start again actively at 1:55. And if you want to stay here and ask me a question right now, just unmute and ask me, or hit the chat bar over there. Okay, so you got a 5-minute break. Stand up, stretch. Don't get sleepy. What type of a can? Okay, so anything that's cylindrical. Okay, I've got a can of soup right here. That's the one I'm going to use. All right, so anything that's a cylinder. Okay. Anybody else has a question, go ahead and ask, either orally or typed. I'm here for you. We're taking a break. If you want to get up, stretch, go to the bathroom, go for it. Because we will not take another break. So this is your chance. I usually won't talk this much. I'll tell you right now. Where's the site with the AP class code? Can't find it in this Schoology thing. Okay, it's in the course description. It's halfway down in the course description for the AP class code. Okay. PDF version of the textbook is available online. They'll let you download it. It's not just for me. I don't have a teacher's version of this thing. I just have the PDF from the website. You can download it. Yeah. Yeah, if you have enough memory. A lot of these little Chromebooks and things don't have a whole lot of memory, so you might want to just link it somehow. Anybody else have a question?
Are we supposed to take notes on the reading?
I would say that the most thorough students would, especially the definitions of those major words that are in the vocabulary that's at the end of the chapter that you're supposed to know, like accuracy, precision, uncertainty, those kind of things, theory. Yeah, so you don't have to take notes, but I'm going to give you brief notes during our classes, and you can fill those in with more notes as you read the chapter if you wish. I hope that answers your question.
Just the entirety of the first chapter, correct?
Yep, up to, I think the text goes from 1 to 28 or so with a whole lot of pictures. I'm going to cover about half of it here in the next half hour. Okay. Will you assign homework, or will we submit it in class or on Schoology? Right now, the homework, since we don't have WebAssign yet, we're waiting for approval for that. It'll be, you keep it and I'll show you my answers and you compare your answers with mine. So I'm not going to have you submit it yet. Not yet. Okay. Maybe in the next week or two, we'll start that. Okay. Any other questions? It's 55, so let's get started. Okay. I'm going to turn on my document cam and we're going to start doing some things. All right. So let me turn this on over here. And I've got my can ready. And I'm going to do I'm going to switch the camera to the Elmo camera. And hopefully you can see my screen pretty big. And I'm going to take notes. Now, if you miss class, I will send you a copy of these notes. This is AP Physics 9, 10, 20. Third period. All right, and we're ready to go. Okay, so the first thing we're gonna do, this is from what, 120 to 250. All right, we're gonna go hard now. All right, so the first thing I want you to do is, this is for a can, and we're in the topic of linear measurements. Okay, now if you can't see my screen, what I'm doing on my screen, you have to kind of shout out to me, okay? So the first thing I want you to do is measure the diameter. That means take your ruler and find out how far across, starting with a line and then guessing the other side of it. Start on a solid line, look at your centimeters, and hopefully you have a millimeter ruler. And if it hits on a line, the last bit's going to be a 0. If it's between lines, then it's a fraction. So I'm going to show you what I did. Measure the diameter and write that down. Now for me, I have 8 full centimeters and I have 2 full millimeters. and I have, it's halfway to the gap, through the gap to the next millimeter line, and I would write that down, okay? 8.25 centimeters. Please do that for your own can. Now, the ruler I'm using has millimeter lines. That means that's the last thing I'm sure about, is how many of those millimeter lines that has been met. And then I have to guess in the gap. If it's not in the gap, it's right on a line, then the last thing I'm going to write down is a 0. In this case, this is your uncertain number. So this is uncertain. This is your guessed at number. Guess number. You always write down a guess number for your instrument. The more expensive your instrument, the more information you can write down, and you don't have to guess until it's smaller and smaller and smaller. So that's okay. This is just a cheap millimeter ruler. Okay. Now, since all three of these, including the uncertain one, all three of these, this is called 3 significant. You use sig figs? Is that what you guys say? Yes? Okay, 3 sig figs. 3 significant figures. Now, significant figures are all sure numbers plus a guess number, plus a guessed one. So for me, that's 3. Everybody got it? Now, the bigger your item that you're measuring, the more significant figures you get. The more expensive your item, your measuring instrument is, the more significant figures you get. But most of the time, for almost all practical purposes, 3 is all you need. Okay, 3 is all you need. Okay, now we've got the diameter. Let's go ahead and get the length, which is actually the height of your cylinder. Go ahead and do that and write that down using our rules of measurement. Using our rules of measurement. So for me, mine was 11.2, right on the line, centimeters. So this is 4 sig figs. And that 0 was guessed at over on the end. That means it was right on the line. If you write down that 0, you guessed that it was right on a line. Okay? Now, since you have your can in hand, I'd like you to look on the label and find out, not in ounces, because that's usually a volume. I'd like you to find out the mass that it shows in grams and write that down. What's the mass of this stuff that you have? Mine's broccoli soup. What is it?
Times diameter times height.
Yeah, pi r squared h, right? So that's the area of the top times the height of the cylinder. So I'd like you to go ahead and do that now, and let's find out what your answer shows up with correct number of sig figs. Go ahead and do that for your cylinder. If you don't have one, is there anybody here? Wave your hand if you're using my data. Anybody here using my data? You are? Okay. Then you and I should agree. So go ahead and do this. So go ahead and do this for your own. What's the volume of your can? And notice that 3 sig figs is just about all you need for almost every calculation. There's rarely any that have 4, 5, or 6. So 3.14. Now the diameter is twice the radius, so we have to divide that in 2. So this is 8.25 divided by 2, and this is squared, times the height for me is 11.20 centimeters. Okay. Now when you're finished, the units, I look at the units before I actually do the numbers. One of my most brilliant students from London actually said that if you look at the units first and the units come out in the type of units you need for the answer, then you're probably got the problem set up correctly. So in this case, we have square centimeters times centimeters is centimeters cubed. All right. And then if we multiply the numbers on our calculator, I get 598 for mine. And Kia, did you get that too?
Yeah, I did.
Okay. All right. You're my checker. Okay. So now, that's three sig figs. Even though my calculator may have said 4, 5, 6, 7, I have to stay with the best three. So if the number after 8 is 0.4 or less, I round it down, right? Leave it at 8. If it was 0.5 or higher, like 0.6, 0.7, then I'd round it up to 599. Question, yeah.
So are we just always going to use 3.14 for pi?
Yeah, that's 3, unless you have pi on your calculator. If you have pi on your calculator, 3.1416 or whatever it is, but usually 3.14 gets you the same answer, all right? Those other ones out there are not so significant. Okay, yeah, I always will unless I have a pi button to push. Okay, so we've got 3 here. We've rounded it off to 3. We can put a decimal point there if we wish. Now I'd like you to find out the density of your can. Now, density has a whole lot to do with buoyancy. You know, is something going to float or not? Boy, all kinds of situations for Titanic and icebergs and ice cubes and all this kind of stuff. Now, we're going to use the symbol rho. Looks like a little flower. It's upside down. And it's R-H-O. R-H-O is the Greek letter, low letter for density, rho, okay? So I'd like to take and find out its mass. So we need to divide the mass and divide that by the volume. And the mass I have from up above, 524. You can do this for your own. Divided by the volume we've just calculated, 598 cubic centimeters. And we see we're going to end up with grams per cubic centimeter, which is kind of a good one. Now, just looking at the numbers, if 524 for me is the mass and the volume is 598, is this going to float or sink in water? Is it going to float or is it going to sink?
Is it gonna sink?
Is the density more or less than 1?
Wouldn't it float?
I know it's gonna.
It's going to sink the
It's going to
density.
float because the density is less than 1, right?
Oh.
So density is less than 1. We have more volume than we have mass, so therefore it's going to float. All right. So let's go ahead and calculate that, and keep 3 significant figs again. And mine turns out to be 0.876 is my density. In simple terms, grams per cubic centimeter. Now, if yours is more than 1, it's going to sink. If it's less than 1, does anybody have one that's more than 1? Anybody have a can that's more than 1? Now, what do you have in your can? Paul, what do you have in your can?
I have Pepsi, so
Ooh, Pepsi. Ooh, it's loaded, huh? It's
Yeah.
not Diet Pepsi?
what?
Is it real Pepsi?
yeah, it's real Pepsi. I just took it out from the fridge or something like that. and-
Oh, so it's going to sink, right?
Yeah, it's gonna sink.
What do you
Pretty
think? What do you think makes it more than 1? Can you say the word sugar?
Yeah. I mean, there's also caffeine in here, I guess. And
That's not very many grams. Come on.
there's
Okay.
also sodium.
All right. So make a little note to yourself on the side. This, for mine's going to float. All right. Because the density of water, liquid H2O is 1.0 grams per cubic centimeter. Okay. So that's kind of an interesting thing that we've just looked at. If you have a can of Coca-Cola, and a can of Diet Coke, which I used to love, you'll find out that one of them floats and one of them doesn't. One of them floats and one of them doesn't. Given down here Paul's situation, probably which one sinks?
The Coke.
Yeah, probably the Coke's going to sink. Probably it's got more sugar dissolved in it within that can, so it's probably going to sink. Okay. All right, we have one more thing to do with our can, and that is we got to convert it to standard units. Now, grams per cubic centimeter is kind of useful because you learned that in physical science. Hey, 1 gram per cubic centimeter, that's water, right? But in real math, real science, we use kilograms per cubic meter. And that's the way we mention real density. And when we do all this aerodynamics stuff, we need to be able to use the real densities. All right, so now I'd like to do, this is called dimensional, like X, Y, and Z analysis. That means you're changing from one type of units to another type of units and not making a mistake, dimensional analysis. So I'd like to start with what we have here, our density. This is of my can, and I'm going to start with my 0.876 grams per cubic centimeter. And I'd like to do some conversions and end up with kilograms per cubic meter, because that's standard metric units for density. Okay, all right. I'm going to give you 2 or 3 minutes and see if you can do it without me. Go. I'll give you 2 minutes. And if you don't quite get it, I'm going to help you within 2 minutes. Diet Pepsi's terrible. Oh, the formula for COA, you got that, pi r squared h, right? Is the volume of a cylinder. Okay. Diet Pepsi's terrible. A kilo is 1 kilogram. Yeah, 1,000 grams. Yeah, those are things you have to know. Okay, when you've got your kilogram, your kilograms per cubic meter density thing, give me a wave on the screen. Wave to me when you think you've got it. 1, 2, 3, 4, 4.5, 5. Oh, you guys are great. Yeah, you guys that only have your names down there, get a picture for me for next time. Okay, you ready? All right, so how do we do this? First of all, now dimensional analysis says you leave everything in until it goes away, until you can cross it out. You leave it in. And I'm sure you did this in chemistry class, biology, and all that kind of stuff. So the first thing we want to do is get rid of these grams. I want kilograms, and I have to put in the correct conversion with the grams to kilograms. So that's 1,000. Now, if I have it on the top and bottom, these 2 grams go and get canceled out. So go ahead and put a line through them. The other thing we need to do is to get rid of those cubic centimeters. Now, I know there's 100 centimeters per meter. I know that by definition. And if I cube that, then my cubic meters are going to end up at the bottom. Cubic centimeters are going to be on the top, and they're going to cancel out. Okay? So the density of my can in metric units, correct metric units, is 876 kilograms per cubic meter. Now, what do you think water would be? Just guess. What would water be?
1,000.
1,000, right? And that's the standard units for pure water at standard conditions, okay? Would be 1,000. So this is less than that, it's gonna float. It's gonna float. So notice that 100 cubed is 1,000,000, and 1,000,000 divided by 1,000 is 1,000, and 1,000 moves that decimal place over here 3 times, and we end up with 876. But we're not done. We got to put this in scientific notation. Scientific notation. Wave your hand if you did this last year in science. Scientific notation, you did. So we need to have this as a number between 1 and 10 times 10 to some exponent and leave in the units out here. And now we can box it in and say, now it's the correct metric units for density, and it's in scientific notation. So you should be able to put things in and out of scientific notation. Now notice that in scientific notation, you cannot put any more digits in there than your last significant digit. So again, this is 3 sig figs. Even though the calculator might give you 4, 5, 6 digits of information, you can only write down significant ones, which includes the guess number. Okay? Any questions so far? Now, let's go and just do a little bit of review. Metric prefixes, you saw on the textbook, there's dozens of them, okay, including mega and nano and micro and all those. We're only going to use 3. We're going to use centa, we're going to use milli, and we're going to use kilo for almost everything in the classroom anyway, okay? Now, centa means 1/100th, and its symbol is a C. Milla is a 1,000th, and that's a little m. And kilo, of course, is 1,000 times, and that's a K. All right, so centimeters, millimeter, kilogram, kilometer, all those kind of things. Any questions so far?
Can you move your paper down, please?
Oh, sorry. Oh, yes, sorry. Yeah, thanks. You have to tell me. Boy, this makes me look like I'm like roast chicken or something. All right. Is that better? Okay. Always tell me if I can change things for the better. I can even zoom in, but if it helps, I can always make things better sometimes. All right. So one more thing for this side, then I'm going to flip the page over. I want you to tell me how many sig figs different things are. Now this is from your textbook now. These are practice questions from your textbook. I'm going to put 3 down here, 0.0009 centimeters, and I have 6 times 10 to the 3rd meters, and I have 6.0 times 10 to the 3rd meters. And I'd like to know how many sig figs each of these are. Write that down and then I'll go over it. And if you can't see it, ask me to make it bigger or move it. All right, these are easy. And I'll explain the rule when we do it. Okay, hey, no yawning. I love it. Okay, don't mind me if I'm a little goofy in the afternoon, okay? I try to have some fun. All right, so the first thing I want to do is I'm going to underline all the significant figures. Now I'm going to just underline that 9. Any zeros that are there to place the decimal point are not significant. So this is a 1, SF, 1. Please write it down, okay? Who have I lost over there on the side? Okay, and then we've got 6. That's only 1. That means they only know that it's 6 kilometers as opposed to 5 kilometers, as opposed to 7 kilometers. They only know, they're guessing at that 6. They're guessing, that's about 6 kilometers away or something. But that's the best guess they can make. Now down here, both of those are significant. A 0 to the right means that somebody wrote it down intentionally. So that's going to be 2 figures. They know that it's closer to 6.0 than it is to 5.9 or 6.1. Everybody set? Everybody okay? Any questions on metric conversions, dimensional analysis, sig figs, measuring linear lines? Any questions? Please ask now. All right. And I'm going to go turn my paper over to the next topic. This is the last one in the chapter, and it's called approximations. Approximations. Now, an approximation is a very useful science term where you don't know exactly what you want, but you want to get an estimate of what do you need, okay? Like how many gallons do you need, or how many tons of something, or how many boatloads. All right, here we go. So this means it's a guess, it's an educated guess to the nearest power of 10. And we're going to practice this today. To the nearest power of 10. This is very useful in some situations. Like how much gas would we need to go from here to San Francisco or stuff like that, okay? All right, so let's remember what powers of 10 are about. Let's remember what 10 to the 0 is, 10 to the 1, 10 to the 2, and 10 to the 3. What are these three things equal to? And then we'll know for what we're doing. 10 to the 0 means what? Uno. There you go. All right. 10 to the first means 10. 10 to the second is 100. 10 to the third is 1,000. So anytime something rounds up or down, so how high could something be and still be 10 to the 0? Well, let's see, it'd be 4.9999 kind of stuff. That still counts as 10 to the 0, right? It's closer to 1 than it is to 10. So if something was 50, it would round up to 10 to the second. Do I see it? And to be 1,000, you'd have to be more than 500. That would round up to 1,000 or 10 to the third. Everybody, I hope you got that. So let's do some samples. Question number 1. To the nearest power of 10, how many AP Physics students are now at Ole? I'm looking only for the exponent. Please write it down. And let me pick somebody at random that looks like they're totally with it. Edith, what do you got over there? 10 to the, if you get it right, I'm gonna give you a high five, come on. Make a guess. You got to unmute.
Sorry, I didn't realize I was muted.
Okay, what'd you get?
10 to the second.
Oh, high five for you. Okay, you ready? You can't see it, but that's a floating high five for you. All right,
Thank you.
10 to the second, of course. I have 3 classes, each one's a little less than 30, and that's 90 students. And 90 is closer to 10 to the second, which is 100, than it is to 10. Thank you, you're wonderful, okay? So next one, let's make it a little more challenging. Number 2, how many heartbeats will you have in your lifetime? And I want you to show me the steps. How do you get there? And I want you to end up with 10 to some exponent, and we'll see if we agree. All right, I'm going to give you a couple minutes to do this. This is takes a little more thinking than how many students do I have. Now write down all the things you have to consider before you get there, okay? Who keeps giving me the peace sign down here? Phoebe? Now send it another minute or two. When you get 10 to the something, I want you to give me a high sign. Who would know that you're doing calculating on the first day of physics? Whew. As soon as you got a 10 to the exponent, give me a high sign. I'm so proud of you guys, working hard the first day. Anybody? Ready? Paul, you done? You are?
I did a very quick, yeah.
Ooh, what'd you get? I'll give you a high five if you got what I got.
Okay, 8?
I don't think so.
Alright.
Akia, what'd you get?
I got 10 to the 9th.
Ooh, you and I, here you go. There's your virtual high five. Ready? Okay. All right. Anybody else get 10 to the 9th?
I got
All right.
something.
Pat yourself on the back because you did well. Pat yourself on the back. That's it. That's it. All right. Let's find out where that 10 to the 8th came from. Ready? Now to do this, we had to know some things. There's 24 hours in a day, and there's 60 seconds in 60 minutes in an hour. Now that hour goes away now. And then we've got to know there's 365 days in a year. What else do we need to know here? Oh, what's the average heartbeat? What would you think?
It
What guys put down for average?
I put 100 a minute.
Whew, on the average? Oh my gosh, they're gonna die. Okay. I know some people have rest around 40 or 50. What would be the average between nighttime and daytime and all that stuff?
I think 60 is about the average.
60 is about the average. I'm gonna use mine, I guess 70. I'm gonna put heartbeats per minute. And that makes that minute go away. So cross that out. I've got days gone, okay? And then we have to figure out how many years in a lifetime, I'll call it LF, lifetime. What's the average lifetime? What do you want to put?
70 years?
Around 70? Yeah, I think the life expectancy for males right now is 78. And of course, you women are going to live longer because you take better care of yourself than we do. So I'm going to use my number, which is 78 years. So that years goes away, and I'm ending up with heartbeats per lifetime. And I've got 2.9 times 10 to the 9th. But since that 2.9 is less than 5, I can round that off to 10 to the 9th. It doesn't round up, it stays. Okay, 10 to the 9th. So all you guys that got 10 to the 9th, hooray for you. Okay.
Aren't you missing 24 hours in a day?
I did that first.
Oh, okay, never mind.
I got it over
Okay.
here on the left. You just didn't see it.
Okay.
That was my fault. There we go. Okay. All right, I've got only 2 more for us, and then we're almost done. So you guys are hanging in there. Thank you so much. You ready? Okay. You love physics challenges, don't you? First of all, I want you to write down the guy's name that came up with all these and made him very famous. His name was Enrico Fermi. Who's heard of Enrico Fermi before? Give me a wave if you've heard of it. You should have if you were in chemistry. Okay, Enrico Fermi is one of the scientists with Oppenheimer and Szilard on the Manhattan Project. He came up with subatomic particles back in Italy. He was Jewish, so he got out of Italy before the Nazis got there and put him in the camps. So he came over and worked down at Los Alamos. After that, he was a professor at the University of Chicago. So one of his teaching techniques was to ask questions like this. So now we call these Fermi questions. We've named them after him. Anytime you're estimating something that you cannot measure directly to get an estimate, we call it a Fermi question, and they're all kind of fun. They're all kind of fun. So his famous question was, how many piano tuners are there in Chicago? Whoa. Hey, let's ask an easier question. How many piano tuners are there to the nearest power of 10 in Olympia Lacey. And I want you to just think about what you would need to know and then come up with a little guess over there. Just think about it a little bit and then come up with a guess. And we're going to see if we can kind of agree a little bit. I'm giving you, this is a 60-second think clock, like on Jeopardy. Dun, 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 dun. Or is that Wheel of Fortune? I don't know. Okay. Everybody got a number down there? Just guess. 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. And of course, it's not 10 to the 3, right? It can't be. So now I'm going to ask the same question that I asked my morning classes, and I think I got a pretty good result out of it. How many of you, and I want you to wave your hand if you have a piano that needs to be tuned in your house. Wave your hand if you have a piano that needs to be tuned. 1, 2, 3, 4, 4. I only see 4. 4 out of 30 or so. Now, how many of you that waved your hand tune your piano once a year or so? Wave your hand again. Nobody? Oh, okay. How about every 2 years? Anybody? How about never? Okay. Okay. Last couple classes though, they said about one, and if your household, you've got about 30 people here, right? And most people that have a piano tune it about once a year if they're active on it. So 30 people times your average household is about how many? 4? 4, so about 100 people. So 1 out of every 100 people need to have 1 tuning, okay, per year. And how many people are there in this area? To the nearest 10,000. Olympia Lacey, come on, somebody give me a number. Don't Google it. What do you think? Anybody got a number?
200,000.
Whew. Okay. I don't think it's that many.
I could Google it.
You did?
I could.
Well, let's just say you're right.
90,000.
90? Did you look it up or did you guess?
Yes.
Okay. Last class guessed 80. All right. So you're kind of in that ballpark. So 1 out of every 90,000 people divided, 1 out of 100th of them would need a piano tuning once per year, maybe. Okay. So let's divide that. So that would give us 900 tunings that need to be done. Okay. 900 tunings. Now, how many pianos could a piano tuner tune? Sounds like a riddle. Do you think they can do 1 a day or 2 a day? I'm going to go 2. Let's divide that by 2. So I need 450 days of piano tuning. Okay? So that means probably 1 person could do this. If they did more, just guessing. It's closer to 1 person, not 10, and not 100, of course, or 1,000. So probably 1 person could service this whole area if they could schedule it nicely, okay? All right, just kind of outrageous. Okay, last one. This is the last one. I know we've got about 15 minutes left. Here we go. How many generations have passed since 0 AD, which is the birth of Christ? How many generations have passed? Now, this is a question from the back of chapter 1, so you're getting this done early. Now, you need to know a little more. There's about 1/3 of a lifetime equals 1 generation. So you should, most of you will have parents and grandparents alive right now, most of you, okay? So it's about 20 years per generation. So if your grandparents are around 60-ish, they could have children that are 40-ish and grandchildren that are 20-ish, okay? That's kind of it, all right? So I'm gonna give you a minute and see if you can come up with what I come up with. How many generations? Come on, I'm making you think. I know it's the end of the day. Ooh! I got a good guesser already. 10 to the 2. Yeah, high five. Woo-hoo. Okay, there you go. All right, it's about 10 to the 2. Go ahead and finish your calculation if you've started it. If you've started it. Okay? So here's how we do it. This is our last calculation for the day, boys and girls. You ready? We have 2020. We're at the year 2020. And we need to know about how long a lifetime is on the average between 0 AD and now. Now, we said that humans now males live an average of a life expectancy of 78. But back then, if you were in your 40s, you were old, okay? So a lot of people died in their 20s and 30s. So I use the average of 50 for the last 2,000 years. So years per lifetime. Okay.
So, Leroy, you need to move the paper.
Yeah?
Down. You need to move the paper down a little.
Oh, yeah, sorry. Okay. So now I've got 40.4 lifetimes. That means from grandparent to grandparent kind of thing. So there's 3 generations per lifetime. So that makes 120, which rounds off to 100, which is 10 to the 2nd generations. Okay? So actually, your 99th, as they would say on, what's that guy, Gates, that does the ancestry thing? Your 99th grandfather was alive when Christ was alive, 2,000 years ago. Your 99th grandfather, which is kind of interesting. All right. So last thing to do is write down your homework, because I didn't write it on the website. I know I have 12 minutes, but I'm not going to keep you that much longer unless you have questions. Your homework is to read chapter 1, and there's some vocabulary at the end, and you should be able to define them. I'll probably give you a matching thing next week where you have to match up the definition with the word, okay? And I'd like you to write some short answers that you can compare to mine on Monday to the 12 conceptual questions. Now, conceptual means probably no numbers, but I found out that the AP is asking us questions like how and why and what materials you're going to use and explain the procedure you would use. It's not just crank out some numerical answers, which is how the APs used to be. You just use a formula and come up with some great answers. But they want to know how you set it up, what did you do, how do you do it, that kind of thing. So that's your homework, and I will put that on Schoology as soon as I have a few minutes. Okay? I'd like you to, we're going to stop now, and I had a questionnaire that I put on there, but it doesn't go anywhere, so I'll give you that again on Monday. It's an AP questionnaire. I put a nice questionnaire there, but when it says submit, it doesn't go anywhere, so I'm going to redo that on Monday. Okay, now if you have any last minute questions, I'm going to let you stay on. I'm going to say thank you for, let me turn off this thing. Hold on, I want to see you. I want you to see me. Let's turn that off. And let's go back to my regular video here. FaceTime video. There I am. Hi. And I'm going to let you go now. So I love your class, and I expect all of you to be excellent performers, getting good night's sleep and doing all the homework I suggest, and having a smile for every class. And isn't that great? So have a great weekend. I'm not going to see you until Monday. And I think we're going to have a good journey together. And if you have questions, you can stay on this and either throw it into chat or turn on your mic and ask me directly. So in Japan, we say sayonara. Okay, sayonara, just give a wave, and then you can go to the corner and say, I'm out of here. Okay.
Thank you.
Okay, thank you. You guys are wonderful. Thank you.
Get on gravitational route to GM over R. It's inescapable, cause I can find velocity. Miss Mills, she taught me. Gonna get 5 on this exam, that's a guarantee. Elastic collisions I've been observing. Your momentum don't need conserving. My love of friction is concerning when you talk physics to me. Talk physics to me.